Yeah, hello, Temiloluwa. How are you? Good morning. So we're going to do matrix multiplication this morning. Matrix multiplication. So let's start with the meaning of matrices, which I'm sure you know. So is an array like this. Okay, so you have rows and columns. So you have, let's say let's say we have two, three, three, four here. So let me pick a color to make it look delightful. So what we have here, we call it row one, row one. So what we have here, we call it row two. Now, let's create another one. The same matrix. We have two, three, three, four. Then I close it like that. So I'm picking my delightful color again. So here we have column one. Here we have a column, we have column two. So that is the matrices. Okay. Now the kind of matrix we have on the board is called a two by two matrix because it has two rows, row one, row two, and it has two columns, column one, column two. So we say this is a two by two matrix. So we have two by three, we have two by four, we have three by three. But you know that when you hear something like three by four, it means that it has three rows and four columns. Columns. So that's the meaning. So for instance, we can have three rows, which means that we have row one, let's say three, because it's going to have four columns. So that row one will have four items in it. So three, four, four, one, 4102, 3321. So you can count the number of rows, row one, row two, row three. That's we can call it R1, R2, R3. Then here we have column one, column two, column three, then column four. Now, if you look at this zero here and you want to name it, you can see that this column is on row two, column three. So we can call this one A number. We can call it position A. A is in position two, comma three because it's in the second row in the third column. So you consider the row first, then you consider the column after. Okay, so that's my brief introduction to matrices. Now let's go to matrix multiplication, which is the one that you talked about. So in matrix multiplication, let's start with the simple one. Let's start with the two by two. Then I'll tell you, it's not every matrix you can multiply. We'll come to that. Let's start with the two by two. Let's say this is A equals, let's say one, two, two, three. That's the first matrix. And let's say the second matrix is a B, which is the same thing now as a 3, 1, 0, 2. Second matrix. All right. So now A times B is done this way. Don't forget what I said. This is the row. Let me pick a red now for clarity or green. This is the row. This is the row here, and this is the row here. Now this is a column here, and this is also a column here. So it's 2 by 2. This one also 2, row 1, row 2, column 1, then column 2. That's fantastic. So the multiplication is now going to be like this. Okay. So you are going to take the entire of row 1 to get the value. If you look at what is going to be here, this is going to be in the first row and the first column. Okay, this very first entry, this is going to be the entry here. The value here is going to be maybe A11. That is, it's going to be first row and second column. So what you do is that you take the values in the first row here, multiply it with the second row here. And this is how to do the multiplication. You say 1, the first value here, multiply the first value here, the first value, the second value here to multiply the second value, then you add. So that's going to be 1 times 3, put it in bracket, plus 2 times 0, put that in bracket as well. Now, you come here. This is going to be, the value here will be A. So we have done A11. So the value here will be A. And what is it? First row, first row, which is 1, second column, which is 2. Meaning that you are going to be using this first row to multiply the second column. All right, the first row here, which is 1, 2, to multiply second column here, which is 1, 2 as well. So it's going to be 1 times 1 plus 2 times 2. So that one is settled. All right, now we can close this one because we now know the extent of our stuff. Then here, what will be here? This is the second row. It will be in the second row and the first column, meaning that you are going to consider the second row now to multiply the first column here. So it's going to be 2 times 3, all right, plus what? 3 times 0. Now the last one here, so that's for A21. Now we are looking for A22, which is going to be the guy here because this is going to be the second row, second column. Okay, second row and the second column. So it's going to be 2 times 1, right? Because this is the second row of A plus, second row, that is 2 here times 1 here, then plus 3 here times 2 there, plus 3 times 2, then you close it. Then you resolve what we have there. So you are going to have 3 plus 0, then 1 plus 4, then you have 6 plus 0, then you have 2 plus 6. This is going to give you 3, 4, 6, and 8. That is going to be the multiplication. Okay, that is going to be the multiplication value. Now let's go to another one. Now take a look at it. For you to, so there's a multiplication rule, all right, and the rule is very simple. Okay, when can you multiply two matrices? If uh a the if you are multiplying a by b, so we can say a and, okay, sorry, let me do it this way. Okay, uh matrix. Okay, before we do, you see here, let me pick a red so that we can use it. So if you take a look at this, you see that we have 1 and 2 here. We multiply it by 2 and 1 here. Okay, it means that the number of this is a column 1, column 2, and this is a row 1, row 2. Then we use 1 here to multiply. We use this 1 to multiply this 3 and add this 2, the multiplication of this 2 and this 0. All right, it means that okay, now, okay, so it means that so the rule says that matrix A and matrix B can be multiplied if the columns if the columns of A is equal to the rows of all right, so that is the law. So if you look at, if they give you any two matrices, what you should first look out for is that are the columns of the first one equal to the column of the number of columns in the first one, is it equal to the number of rows in the second one? If that is the case, then it means you can multiply the two matrices. Now let's look at another example. So I'm opening another page. Okay, so now let's look at this and tell me, okay, if they can be multiplied. This let's say this is A, then this is a two, two, three, one, two, three. Then this is B. This is a let's say um two, two, one, 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 one. And we multiply this. If you look at it, you can see the number of columns here is 1, 2, 3, and the number of rows here is 1 and 2. They are not equal, so it means they cannot be multiplied. Because if you look at it, since you are going to use 2 here to multiply 2 here, use this 3 to multiply this, what will you be using this last 3 to multiply here? It's not there. So it means that for you to be able to multiply this, you may have to add an extra row to it so that the number of rows and columns will be okay. So we can say that A, B is not possible. A, B is not possible. So now let's look at the one that is quite possible. So let me move on to another page. Let me create another page so that we can look at the one that is possible. Let's now look at let's look at 3, 2, 1, 1, 2, 3. That's what kind of matrix is this? This is like I said, we consider the row first. How many rows does it have? One, two. How many columns? Three. So this is a 2 by 3. Sorry about that. That's a 2 by 3 matrix. Let's call it A. And let's look at B. Let's look at B. Let's look at B. Let's open it up like this. Let's say this is a three. Let's make it a square matrix. 3, 3, 3, 1, 2, 0, 1, 1, 1. Okay. Now, how many columns do we have here? We have 1, 2, and 3. How many rows do we have here? We have 1, 2, and 3. So both of them can be multiplied. This is a 3 by 3 matrix. B is a 3 by 3 matrix. Okay, so now let's look at the multiplication. I'm going to be faster now. So we can now say AB equals, so let's open the first bracket. So 3 times 3 here. Okay, you use everything here to multiply everything here. Okay, so we are going to have, and of course, it's a linear multiplication, or I can't linear combination. Sorry, it's not linear combination. Multiplication, linear combination. That's what we call it. So this is going to be 3 times 3 plus 2 times 1 plus 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 1 times 1. That's the first one. All right. So would we have something here? Let's see. This that is going to be the item here will be in the first row and second column. So can we use this first row to multiply the second column? Yes, we can do that. So we can have 3 3 plus 2 2 plus oh they're the same 1 1. Okay, so that is done. Now, can we have something here? Let's check. Uh, yeah, that's going to whatever we are going to have here will be 1 3. That is in the first row and the third column. So so can we have it? Obviously, we can. We can still multiply this with this guy here. So we are going to have here we're going to have 3 1 plus 2 0 plus plus 1 plus 1 1 plus 1 1. Okay, so I think we can close this one. Now let's now move. Can we have something here? What are we going to have here? This is the row 2. This is going to be row 2, column 1. All right, row 2, column 1. Okay, so do we have a row 2 here? Yes, we do have row 2 here. Okay, then column 1, do we have a column 1 on the other side? Yes, we do. So it's going to be 1 times 3. This is the linear combination now. 2 times 1 plus 3 times 1. We are done with the first one. And the second one is going to be 1 times 2, sorry, times 3 plus 2 times 2 plus 3 times 1. And the last one is going to be 1 times 1 plus 2 times 0 plus 3 times 1. All right. Can we still have an item here? Is it possible? It's going to be row 3 here. Then we don't have a row 3. So it means that we can no longer continue. So we just resolve what we have there and we can say, hey, let me minimize this stuff here. Sorry. Okay. So we can now say we have A now will be equal to, our A will be equal to, we just have to be careful now. This is 9 plus 4, I mean 9 plus 2, which is 3. Sorry, 9 plus 2, which is 11 plus 1, which is 12. Then here, this is 9 plus 4, which is 13 plus 1, which is 14. Then here we have 3 plus 0 plus 1, which is 4. And down here we have 3 plus 2 plus 3, which is 8. Here we have 3 plus 4, which is 7 plus 3, which is 10. And here we have 1 plus 0 plus 3, which is 4. So that is the multiplication. Now let's take a look at this multiplication. That's A times B. I wrote A, just A, B. Okay, so this is A times B. Now, if you are multiplying two matrices, what will be the outcome? It will be, so here, to be able to multiply two matrices, the number of columns of A must be equal to rows of B. Okay? Then the outcome will now be, outcome, outcome will be the number of rows of A by the number of columns of B. So if you look at it, A here has two rows, row 1, row 2. B here has three columns, 1, 2, and 3. So the outcome will be 2 by 3. And if you look at this, it's a 2. This is a 2 by 3 matrix. I think that will be okay. Now let me give you an exercise which you do it and post it to me. All right, so solve these problems. Find out which matrices can be multiplied. Okay, and predict the dimension of the results. I'll tell you what to do, don't worry. Number one, so let's say 1. So let's say this is A, matrix A is 2, 1, 1, 1. Matrix B is 1, 2. That is that kind of matrix. Can it be multiplied? That's one. Number two, um, A equals 3, 3, 2, 1, 1, 0. Can you multiply it against B, which is um, 3, 3, 3, 1, 2, 3. Okay. Can you multiply it? All right. Now C, let's make our 3A equals 3, 2, 1, 0, 0, 1. Can you multiply it against um, 3, 2, 1, 1, 1, 0? Can you do that? So if the ones you can do, tell me what will be the rows and column of the. Anyways, solve this problem, these three problems, and let me have the solution. Thank you.